I know it doesn't say recording because I'm not recording through Zoom. I'm recording to software called Camtasia. So I don't know if you guys want to say hello. I'll upload this to YouTube. Abdul Kareem and Flores, do you guys want to say hi?
Hi, YouTube. Hey. Hello.
Okay. You guys are funny. Y'all are funny.
Math life.
Math life, math life. So let me know. So Estrada, let me know because I'm not keeping an eye on it. If you see a little icon flash that says someone's in the waiting room, and if there's someone in the waiting room, I'll let them in. So just keep me in the loop. Should we get started already? And then, I mean, right now we won't do anything fancy just yet. Just talk the basics. Okay. So let's get started already. So look what I put here, guys. I composed this for you guys. It's some of this I was able to cut and paste from different assignments, right? But the facts about derivatives, f prime, and f double prime. And I know we've done an overview already of this, but this is like a double overview. And after today, we will be really good at everything now. So first and foremost, I put 15 little rules here, right? And then the first one says a critical number occurs at a next value of f of x where the derivative is 0 or undefined. All relative min-max will occur at a critical number. It could also be an absolute min or max, and that occurs at an endpoint. And I talk about that in a little bit. Sometimes some textbooks don't call endpoints relative mins, relative max. They just call them, it could be an absolute min or absolute max. It all depends on what textbook you have. Number two, f prime is positive. That means f of x is increasing. I think we should know that one already by now. Number three, if f prime is negative, f of x is decreasing. I think we're pretty good at those. Number four, a relative max occurs at the next value where f prime goes from positive to negative. So that's what you want to highlight. You have a max, a relative max, if f prime goes from positive to negative. You have a relative min if f prime goes from negative to positive. Let's see. If you have a critical number and you are concave up at that critical number, then that's a min. So for an example, let me do something like this. So that's concave up. Here's a critical number because my derivative is 0. So notice that that critical number is a minimum. So that's number 6. And then if x equals c is a critical number and you're concave down, that's what that means, right? F is concave down. Then f has a relative max. So here's a visual. I have a critical number at this coordinate. There's my x equals c. And notice that that is definitely a max because you're concave down. If the second derivative is positive, then that means f of x is concave up. It also means that f prime is increasing. And I think I put that in here, but just in case, f prime is increasing. Admit. And if f prime prime is negative, that means that f of x is concave down. So that also means that f prime is decreasing. Sorry about all that, guys. And here it is. If f prime of x is increasing, well, notice it says f prime is increasing. That means f of x is concave up. Well, yeah, that means because f prime prime is positive. If f prime is decreasing, then f of x is concave down. Well, yeah, because f prime prime is negative. See? And then question 12, it says if f of x is concave up, f prime, okay, well, that's what we were talking about over here, right? Then the second derivative is positive. This is how you say positive, guys. And then f prime is increasing and tangent lines are below f of x. So that means this. That means I'm concave up. And look, and your tangent lines, look, they're below the f of x curve. They're below your curve. So that would be, if you were to use that tangent line to make an approximation for something close to the point of tangency, it will be an under approximate. But that's for, we'll talk about that when we get to that. And then if f of x is concave down, that means the second derivative is negative. That means f prime is decreasing and tangent lines are above. So sure enough, concave down, this is f. And check it out, guys. My tangent lines are above the curve. So I've already used those tangent lines to find an approximation of f close to, sorry, the fire drill's freaking me out here. There is no fire, they're testing, they said that before. So yeah, if you use a point of tangency and you're close to that point of tangency, the tangent line approximation will be an over approximate because it's above the curve, right? Above the f of x curve. And then a point of inflection occurs when the f prime prime changes sign. Yes, because a point of inflection means where you're changing concave up to concave down or concave down to concave up. And this is the same as saying f prime is changing from increasing to decreasing and vice versa. And you could also say, I guess here put f prime has a max slash min. So, I'm sorry for the fire drill again. Hopefully that's close to the end. I think they're testing like every sensor here. And then absolute max min on the interval occurs at endpoints or critical numbers. So you can have an absolute max min at an endpoint. So that's why we always do a candidates test to check to see if we have a max or a min. So hopefully that made sense. Did all that make sense, guys? Do you guys agree with that? Abdul Kareem, Flores, Espinosa, I think I saw you in here.
Yeah.
Yay. Awesome. I'm happy, guys. I'm happy. All right, so here we go. Stop me whenever we get to something that looks kind of fishy. So here we go. It says, what are the critical numbers of f of x? So tell me, how do I get critical numbers?
It's where your f prime is 0.
Where f prime is 0 or?
Changes signs. Undefined.
Undefined, perfect. But then we got a polynomial, so we're just going to take a derivative, and then we're going to factor and all that good stuff. So here we go. The derivative of 3x to the 5th. Minus, perfect. I equal that to 0. And just like Estrada said, I'm going to factor. What do I factor out? An x squared and perfect. So when I factor out a 15x squared, I'm going to have x squared minus 4, no? 15 goes into 64 times? No, you're good, you're good.
Yes. Yep.
I equal that to 0. So I get two values. I get x equals 0 as one of them. And from x squared minus 4, remember x squared minus 4 can be 0. 0 times anything is 0. You can say x squared equals 4. And then from that you can say x equals plus and minus 2. So these are my critical numbers. What do you guys think? Yeah, not bad, right? Pretty straightforward, nothing crazy. All right, let's go on to the next one, guys. It says, when is f of x increasing? Well, f of x is going to increase whenever f prime is positive. So I'm going to do, here's what I'm going to do. I'm going to do a number line. And I'm going to put -2, 0, and 2. And I'm going to label this as f prime. All I care about is the signs. I know that 15x squared is always positive, because any number that I square is going to be a positive number. So I'm just going to focus on the x squared minus 4. So I choose a number to the left of -2, like -5. It doesn't matter, whatever number you want. -5 squared is 25, and 25 minus 4 is a positive number. I choose a number between -2 and 0. And like -1, -1 squared is 1, and 1 minus 4 is going to be a negative number. Again, a number between 0 and 2, like 1. 1 minus 4 is again a negative number. And if I choose a number bigger than 2, like 4 or 5, 5 squared is 25. 25 minus 4 is a positive number. So there it is. Where am I increasing?
From -infinity to -2, and then from 2 to infinity.
Perfect, guys, perfect. So I'm going to write a statement. So I'm going to write f of x is increasing on the interval, parenthesis, -infinity all the way to -2, and you can close it at -2. You can also put parenthesis, but that's a debate for another time. The more correct should be bracket there. And from where? 2 to infinity. Perfect. Because, can I spell because? Because f prime is positive on these. You know what? Since I put a bracket, I'm going to say f prime is positive on -infinity to -2, parenthesis, and 2 to infinity, period. And the reason I did that, guys, in case you were wondering, because I was about to say because f prime is positive on these specific intervals, I had to change it because right at -2, F prime is not positive. F prime is 0. But the reason why I included a parenthesis is because you increase and decrease on an interval. Like right at the pixel right at -2 is actually bigger than the pixel to the left of -2. So at -2 point, let's see, what's to the left? 2.0000001. That pixel is smaller. Does that make sense? Like pretend it is a pixel, and that's at -2.001. And then here's another pixel at 2, but that one is way over here. So I know I put a gap, but there's infinitely many pixels. This pixel is bigger than this pixel, so you're increasing until you hit this value. And then after that value, you start going down. So yeah, so I don't know, maybe it's safe if you just put parentheses on everything, but you might make some professors mad and some math people mad. So yeah. Okay, here we go. When is f of x decreasing? Well, you're decreasing from -2 to, well, really, okay, I know. Some of you might say you're decreasing from -2 to 0, and then you have a horizontal tangent for a moment, and then from 0 to 2, you continue to decrease. But what's better? From -2 to 0 or from -2 to 2? What's better, to say you're decreasing -2 to 0, union 0 to 2, or is it better to just say -2 all the way to 2? Which one do you guys think is better, A or B?
Which one?
Which one?
A.
No, B's better actually. Let me tell you why, guys. It's that thing that we were talking about. Okay, I do know how this graph looks, but I'm just gonna draw something random. So let's say here's my 0, and here's what it's happening. It's doing that. But at this pixel, to the left, that pixel is larger, like it's higher. And to the right, that pixel is lower. And what am I talking about? I'm talking about this reference here at x equals 0. So to the left of 0, I have pixels that are larger, the y value is larger, and to the right of x equals 0, I have pixels that are smaller. Does that make sense? So even though you flatline right here, you don't increase. So you're going to say that you decrease from -2 all the way to 2. Does that make sense to you guys? You can type Y in the chat box and say yes. Perfect. Yay. Awesome. So
Would it be wrong? Would it be wrong if you were to do the union? Like, would it be wrong?
I guess I don't know if well, I do know. I don't technically you wouldn't necessarily be wrong, quote unquote. But Dr. Cannon from Baylor, and I spoke to him directly, so hopefully he remembers me. Hi, Dr. Cannon, if you're seeing my YouTube channel, which you're probably not. But Dr. Cannon from Taylor said something like, "Well, you're not wrong, but is there a better answer?" And the answer to that is, yeah, there's a better answer. The better answer is you're decreasing from -2 to x equals 2. So there's the answer, Abdul Kareem. So check it out. Sorry, we have Mr. Quinones that just came in. I am recording. I have a Zoom session, and like I'm doing like 4 or 5 things at one time. If I were to try to do it on this thing, it would crash. Yeah, it would have crashed because it doesn't have a dedicated graphics card. So this guy would have crashed, but this is able to handle it. Barely. If I try to do another 2 or 3 things, it might crash. But next time the laptop studio 2 maybe. All right. So here we go. Sorry guys, I had to chat with Quinones real quick. All right. So I'm gonna go f of x. Oh, you can stay here. You can stay here, Quinones. Nah, you guys want to come check out. All right. F of x is decreasing on the interval -2 to 2. Since f prime is negative on -2 to 0 and 0 to 2. Full credit. Hold on, I thought I have a question. Hmm? Oh, you can write f prime, but no, you wouldn't. I'm just so used to just writing f prime, f double prime. You can say f prime of x, you can say f prime of x or f of f prime. Yeah, same thing with f. You could have said f is decreasing instead of f of x. That x just means that you have a function with respect to the variable x. But it's understood in the math world if you just say f is decreasing. You know what I mean? All right. The question was if I have to write the x in here or not. You could. Sometimes I have a bad habit of not writing it in. I probably should be writing it in, but you don't have to. All right. At what x values? Sorry, the fire drill's going on. At what x value does f of x have the relative max? Justify your answer. Okay. Well, I have a max whenever the derivative goes from what to what? Positive to negative. So I have a max where? Yep, at -2. That's it. That's the only location. That's the only location. So I'm going to write f of x has a relative max at x equals -2 since f prime changes from positive to negative at x equals -2. And I know it sounds silly to restate it again, but just state it again. It's not a big deal. Hey guys, we had some visitors. Yay! And then we got this in here, so hopefully it's nice and toasty. Yeah. So, and we just started. We're on the second page, and I'll show you what we did. So on the first page, these are just facts, 1 through 15, and then we just finished the second page, and we're about to do the third page here. All right, so now it says, what x value does f of x have as relative minimum? Justify your answer. I have a minimum when what happens?
Go from negative to positive. When f prime goes from negative to positive.
Perfect, f prime. Now, the thing that we have to worry about here, guys, that we always, I keep seeing it even now, you guys keep saying the word it. Oh, I have a minimum when it goes from negative to positive. The word it is not telling me anything. Well, I mean, it's telling me something, but what is it? Does that make sense? So make sure you tell me, guys, you tell me you're specific. I'm going to write f of x. And by the way, I have a minimum when it goes from negative to positive. So you read a graph left to right. So where do I have a relative min at? At x equals? At x equals 2. So here we go. I'm going to write f of x has a relative. Yeah, this laptop is barely able to handle all this because I can tell if I try to open up more apps, it won't be able to do it, I don't think. F of x has a relative minimum at x equals 2 since f prime changes from negative to positive at x equals 2. Don't worry, this is not same old, same old. You're going to see in a little bit, we're going to change it up. We're going to do some cool stuff that we haven't done in the past, including you, Paracella. We're going to do fun stuff. You're going to see. I put a lot of thought when I was typing last night. All right. When is f of x concave up? Well, to know about concavity, we got to take a what? A second derivative. Yeah, perfect. Sorry, there's a slight delay, a little delay, but we're so good. So I'm gonna take this expression right here, the fifth. Is that my derivative? Yeah, 15x to the fourth minus 60x squared, and I'm gonna take a derivative. So a derivative of that. So that's gonna be my second derivative. So I'm gonna write f prime of x, and I'm gonna write 15x. I already forgot. What was my derivative? 60x squared. Thank you. And I'm gonna write f prime equals the 15 times 4. 15, 30, so is that 60? And let me know, because I make mistakes all the time. Minus, and 60 times 2, what's that? 120x. And I'm going to set this equal to, what can I factor out? Yeah, algebra never goes away, guys. 60x. And then I'm going to have, so if I factor out a 60x, you can come in. So if I factor out a 60x, I'm going to have x squared minus, how many times does 60x go into 120? 2 equals 0. So here are my critical points. Dr. George, a long time ago, told me that they're not critical points because the critical point is only when the derivative, the first derivative, is equal to 0 or undefined. And so she goes, well, technically, that's not a critical point. So Dr. George, if you're watching my video, I'm sorry. But yeah, something's happening there. So, set it equal to 0. So x equals 0 and x equals plus minus square root of 2. How do we feel? Abdul Kareem, do we feel okay?
Yeah, I'm good. My little sister's trying to learn calculus, but she's not.
Hey, Math Live, little sister, whenever you come to YAA, we're going to hit you with this. And, I'm going to upload this to YouTube. And I'm gonna tell you, hey, do you remember when you were doing this with your big sister, Abdul Kareem? And I'm going to come back to this video, and we're going to see it. All right, so here we go. I'm going to do my number line. I'm going to title this F prime prime. I'm going to go negative square root of 2. 0 and square root of 2. So catch up to there. And I'm going to plug values into this guy. Let's see, into this guy, because it's probably easier. So check it out. I'm going to pick a value to the left of negative square root of 2, any value, like negative 10, negative whatever, negative 100, whatever you want. If I pick negative 10 squared is 100. 100 minus 2 is a positive value. And then 60 times negative 10, yeah, I know, it's going to stop right now, guys. 60 times negative 10 is a negative value. What's positive times a negative? Negative. I choose a value in between negative square root of 2 and 0, like negative 1. Child, how do you know the negative 1 small? Well, the square root of negative 1. Well, okay, don't talk about square roots. Square root of 1 is 1, and then put a negative in the front is negative, right? So negative 1 is in between those values. So negative 1 squared is 1. 1 minus 2 is negative. 60 times the negative 1 is negative. Negative times a negative is a positive. See? If I plug in a 1, 60 times 1 is positive. 1 minus 2 is negative. Positive times a negative, negative. And if I plug in a number bigger than square root of 2, like 4 or 10 or 3 or whatever, 60 times positive is positive. 3 squared is 9. 9 minus 2 is positive. Positive times a positive is a positive. Okay, where is f of x concave up? Between
negative 2 to 0.
Perfect. Now, this one, use parentheses always. If you're scared, if you're like scared about increasing, decreasing, and Chavez said brackets, and I'm so confused about brackets and parentheses. If you're scared, then use parentheses for everything, and you'll be fine. You'll be fine. All right, here we go. I'm going to say f of x is concave up on the interval, parenthesis, negative square root of 2, comma to 0, close, and square root of 2, comma to infinity, close, since f prime prime is positive. So this is how you say positive, f prime greater tan 0. And on this one, since I put parentheses on everything, you can say on these specific intervals. On these specific intervals. My laptop is not quite lagging, but it does lag here and there. I'm using my hotspot, so it might lag even more for you guys, so I'm sorry about that. But yeah. All right, when is f of x concave down? All right, let me change the color. It's pretty much the same logic, but instead of the positive, I'm looking for the negatives. F of x is concave down on parenthesis negative infinity all the way to negative square root of 2 and parenthesis 0 all the way to the square root of 2 since f prime prime is negative, so the second derivative on these specific intervals. And then finally, well, not finally, but here's question number 8. What x values does f of x have point of inflections? Point of inflections happen. Abdul Kareem got kicked out by accident somehow. I let her back in. Hey, Abdul Kareem, sorry that we got disconnected. It might have been me. I don't know. What x value does f of x have points of inflections? Point of inflections whenever the second derivative changes what? Changes signs. So I'm going to write f of x as points of inflection at x equals, let's see, negative square root of 2, 0, and square root of 2. At negative square root of 2, 0, square root of 2, since f prime prime changes from, I always state the first one first, negative to positive, negative to positive, and vice versa at those specific x values. Yay! F of x has positive inflection at x since f prime changes from negative to positive and vice versa at those specific x values. Perfect. Full credit. Okay. How do we feel so far? Okay. All right, let's go to the next one. So now look, all we're doing is verifying. This is f of x. Got it looking real nice in here. Look at the analysis. Look at the next time I put a grid. So it says, does all the analysis above work for the graph of f of x? Well, notice, and I guess I'll code it here. Notice that f of x is increasing. So wherever f prime is positive, well, f prime is positive here, and f prime is positive on this one. So let's go back, and I'm going to look at my little sign here and see if f prime is positive on those. Oh, we have to go way back. F prime is positive, negative infinity to negative 2 and 2 to infinity. And OMG, look at that. All the way to negative 2 and 2 to infinity. Cool, right? Now look, let's look at the concavity. I am concave down all the way until about right there. Yeah, that's about square root of 2. Negative 1.4, I think, is what square root of 2 is, right? Something like that. So concave down. So, So that's f prime prime is negative. And then, let's see, where else am I negative? From 0 all the way to about there as well. F prime prime is negative. Look at that. Burnt orange, concave up. F prime prime is positive. And concave up. I'm trying to color code. F prime prime is positive. So concave down between negative infinity all the way to negative square root of 2. And it looks like square root of 2 all the way to infinity. And sure enough, that's what I have up here. And yeah, everything checks out. Everything checks out. Everything checks out. Isn't this awesome, guys? We're doing math on a Thursday. There's no school technically. Like, life is good. Life is good, guys. All right, let's keep going. All right, so look, this is the cool stuff that I wanted to do. This is what I feel like I needed to do more of last semester. And there was deltas. I don't know if you remember, but I took it out because we were like, oh, we're all having a hard time. So I think I might put that in. We'll make it optional. Because it is kind of tricky. If you don't have a mouse, it's going to be kind of hard. You need a mouse for this part through delta. All right, so look what it says. Let f of x be a continuous function such that, so this is the first thing we're going to do. So we're going to graph f. So f of 2 equals negative 1. So go to 2, negative 1, put a point. Sketch a possible graph for f of x given the information below. All right, we're going to go slow. For x less than 2, f prime is positive and f prime prime is negative. So if f prime is positive, you read a graph left to right. Sorry. I'm trying to throw shade to the fire. I'm giving it the look, but it's like, it's not even, okay, I'll stop. All right, f prime is positive. So if f prime is positive, what does that mean about f? That f is increasing. If f prime prime is negative, what does that mean about f? No, negative.
You said it down. Okay.
Right. Yeah, I have a max, right, at that critical. Okay, so increasing, concave, down, f. Right? Because, okay, yeah, be careful. We got to, okay. So positive and negative. So I'm going to draw an increasing graph, concave down. So it's probably going to look something like increasing, concave down. Something like that. See? And then look, at x equals 2, I have a horizontal tangent. So there's my horizontal tangent. And I'm still concave down. and then negative, and I'm still concave down. So negative means that if f prime is negative, that means that f is decreasing. So I probably look something like this. See? And there it is. That's it. Was that cool or not? All right, let's go to number 2. We're going to do all these little scenarios. Again, we're going to put what point? It's for the same graph. So 2, -1. Put that point in there first. Now, f prime is positive, so that means I'm increasing. And f prime prime is negative, so that means f is concave down. So here we go. Increasing, concave down. I still have a horizontal tangent because it says 0. And then it says f prime is positive and f prime prime is positive. So that means, what does that mean? Increasing concave up. Check it out. It is a point of inflection. Yes, everything checks out. We're good. We're good, guys. So I think this is what we needed. We should have done some of these during notes. I'm sorry that we're doing it right now, but it's all good stuff. Good stuff. I know we did one AP question, a real one, but we needed more problems. All right, so we should have done this before we did that delta math. All right, f prime is okay. First, let's put the point 2, -1. That was given. All right, to the left, f prime is negative and f prime prime is negative. So I'm going to be decreasing, concave down. So decreasing, so I'm going to go above that line, that point, and I'm going to go like this, decreasing, concave down. See, decreasing, concave down. And then they tell me I'm undefined, so that means I probably have a corner or a cusp, and I am, because look, the next one, it says positive, positive. F prime is positive and f prime prime is positive. So that means f is increasing, concave up. So it looks like it's going to look like that. Look at that. It definitely looks like a corner to me or a cusp to me. We're winning, guys. We're winning. Let's go to the number 4. Plot that point again. 2, -1. All right. Positive, positive. So what does that mean? Well, f prime is positive. F prime prime is positive. What does that mean? F is increasing, concave up. So I'm going to write, let's see, increasing, concave up. So I'm going to do something like increasing, concave up. I'm undefined. And then f prime negative, f prime prime positive. What does that mean? Decreasing, concave up. Look at that. That definitely looks like another cusp or corner to me. We're winning. Let's go to the next one. Put that point again. F of 2 equals -1. So we're graphing f again, guys. We're just graphing f and f over and over and over again. So next time, next year, should I do this first before we do that delta?
Honestly, yeah, because it's like visualizing and comparing it. I'm like,
Now, are you liking this?
oh yeah.
Okay, so we're not.
I would recommend it.
So, but are you guys liking this? Like, I'm not wasting your time, right? Like, you guys feel like we're doing good stuff here.
Yeah.
Okay.
Yeah.
Good. Thank you, guys. Thank you. All right. F prime is negative. No, guys, I was up to like 130 typing this out, like, formatting it. I put a lot of thought. You know how long it takes to just get a simple grid? Okay, sorry. Let's not go in there. All right. F prime is negative. F prime is positive. So that means that F is decreasing, and F prime prime being positive means that F is concave up. So decreasing, concave up. So here it is. Decreasing, concave up. And then they tell me I have a horizontal tangent. So it looks like, there it is. It looks like a horizontal tangent to me. And then I see positive, positive. So that means increasing, concave up. So it looks, there it is. Let me draw it a little better. So it looks something like this, guys. There it is. It looks like a parabola. Cool or not cool? All right. Here we go. I think we're done. Look at all that beautiful math, guys. Beautiful, beautiful, beautiful. You are beautiful, no matter what this. Okay, I'll stop. Should I delete that? Okay, I'll keep it. All right. I remember we did a question similar to this one on this. We did, I think it's from 2005 AP exam, but these numbers are just made up. But I think we did something similar to this one. Let it be a function that continues in the closed interval 0 to 3. The function f and its derivative have the properties indicated in the table below. Find the x-coordinate of each point at which f attains a relative max. Justify your answer. Okay, a relative max on the open interval 0 to 3. So put that in there in your notes here. Put open interval 0 to 3. All right, I have a max whenever f prime changes from what to what? Positive to negative. So is there a location where I do that?
At 2.
At x equals 2. It's okay if it's undefined. That's a critical number, guys. 0 or undefined. So I'm going to write f. Notice that I didn't say f of x. It just says f. That's fine. F. You can say f or f of x, like the question that Estrada said earlier. F attains a relative. Yeah, it's the same. It doesn't matter if you say f or f of x. A relative max at x equals 2 since f prime changes from positive to negative at x equals 2. Full credit. And that's all they wanted. And it says, find the x-coordinate of each point of inflection on the graph of f, justify your answer. Remember, you're continuous. So I have a point of inflection. When do I have a point of inflection? Whenever what? When the second derivative changes signs. F prime changes signs. So I'm looking. Let's see. Undefined, negative, 0, positive, undefined, negative. So how many points of inflection do I have? No, not 3. 2. Where and where? At x equals 1 and x equals 2. Because f prime changes from negative to positive and vice versa. So I'm going to write f has points. Oops, put the I there. I'm sorry, I put the little points of inflection at x equals 1 and x equals 2 since f prime changes, and you always want to put the first one first. Changes from what? Changes from negative to positive and vice versa. If you want to say positive to negative, that's fine. And vice versa at those specific x values. And there it is. All right, now we're going to sketch. So let's see. First, plot the points they give you. I have a point that tells me that f of 1 equals 2, and it tells me that f of 2 equals 3, and f of 0, sorry, I didn't write f of 0. F of 0 equals 1, and f of 3 equals 2. So plot all those points. 0, 1, so 0, 1 point. I'm just getting them from here. 1, 2, so go to 1, 2 point. And then 2, 3, 2, 3 point. And then 3, 2, 3, 2 point. So there it is. I plot the points first. Are we cool? All right, now I'm going to see between 0 and 1. Notice that f prime is positive and f prime is negative. So f prime positive, that means f is increasing, and what's the concavity?
I'm like, what?
What's my second derivative?
Oh, negative.
So f is concave down. So increasing concave down between 0 and 1. So here it is. Increasing concave down. So it doesn't have to be perfect. Increasing concave down. And then it tells me that my slope is 0. So I have a horizontal tangent right at 1. And then it's positive again and positive again. So that, well, no, it's not positive again. It's positive again for f prime, but positive for f prime. So that means increasing concave up. So horizontal tangent, increasing concave up. Boom. And then notice it tells me I'm undefined, my derivative, and my second derivative is also undefined. So usually if the first derivative is undefined, the second derivative is undefined. So that means I have a cusp or a corner. And let's see, between 2 and 3, negative, negative. So f is decreasing and concave down. So draw that between 2 and 3, decreasing concave down. And sure enough, there it is. It looks like a shark fin. So there is a corner there at x equals 2. And then finally, oh, is that it? I think that's it. We're done. There it is. That's how it looks, guys. That's f. Make sure you label your graph. Yeah, man, guys, we're doing so awesome. All right, here we go. It says, let f of 1 equal negative 1. So that's the first thing you're going to do. F of 1 equal negative 1. Put a point at 1, negative 1. That is f prime is given below. So this is f prime. This is the f prime graph. What do we know about f of x? Sketch a possible graph. Okay. Look at all the different ways we're doing this, guys. Between x equals 0 and x equals 1, f prime is negative. Do we see that? But f prime is increasing. So between 0 and negative 1, if this helps, you can write f prime prime is positive. Do you guys see that? So that means on f is decreasing because f prime is negative, but f is concave up because f prime prime is positive. Or you can also say because f prime is increasing. Does that make sense? Okay, cool?
Yeah.
Perfect, perfect. So here we go. So from 0, let's see, where am I going to go? X equals 0. So I guess it doesn't tell me how much. So start anywhere, but make it go decreasing. Did they give me an f of 0? No. Decreasing and concave up. So I'm going to go like this, guys. I know that I have a horizontal tangent right at 1 because it's touching the f prime graph. And then after I pass x equals 1, f is increasing because it's positive, and I'm still concave up. And it looks like I stop at 2, so I'm just going to go like this. And there it is. How do we feel? Okay. All right, let's go to the next one. Let f of 2 equals 3. The graph of the derivative of f of x, f prime of x, is given below. So determine on interval. Okay, so we're going to have to sketch it in a little bit, but we're not there yet. So letter A, determine the intervals where f of x is increasing and or decreasing. Okay, where am I increasing? So I'm going to assume
from -1 until 2.
Yeah, yep. F is increasing on interval. If you want to use parentheses, you can. -1 all the way to 2. Brackets is the better choice since f prime is positive on, and notice that I put positive, and notice that I'm using parentheses. Because right at -1 and right at 2, it equals 0. And I guess you wouldn't be wrong. You'd probably still get full credit if you did this. But then if you put that equal sign there, then you got to go like that. So if you did that, do that. But if you don't put the equal sign, then you got to use parentheses. They're both correct, but this is probably the preferred method that mathematicians would like to use. All right, decreasing. F of x is decreasing. Assuming there's arrows here like that.
From -infinity to -1.
On -infinity to -1 bracket and to infinity. Perfect. F of x decreasing -infinity to -1 and to infinity since f prime is negative on -infinity to -1 parenthesis and 2 to infinity parenthesis. If you put the equal sign on the bottom, then I guess you could use brackets again and you'll be fine. But there it is.
Chubb, when do you use the union? Do you only use the union when it's like the same number?
No,
like if
I could have used the union. I could have used the union because union just means and. But I like to spell it out. You know, because why not? You know. Determine the intervals where f of x is concave up and concave down. I love it. Where am I concave up?
From -infinity to 1/2.
Yes. Why?
Because f prime is increasing, which means that f prime prime is positive.
Perfect. The best answer, guys. So let me tell you guys right now, for y'all, as you guys continue with your math life journey, the best answer is to use whatever they give you. So if they give you f prime, use f prime. So I'm going to say f of x is concave up on the interval -infinity, comma, all the way to 1/2. Use parentheses on this. Since f prime is increasing on this specific interval. And where am I concave down?
1/2 to infinity.
Perfect. F of x is concave down on half to infinity since f prime is decreasing on this specific interval. Don't worry, guys. I won't keep you here another 10 more minutes. I know you guys want your Thursday back. All right. They want me to sketch a graph on letter C. So I know if you printed it out, you're going to have to be going page to page. I have it already here, so I can just scroll up. So the first thing I do is plot the point they give me. So they give me this point, 2, 3. So that's what I'm going to plot. So I'm going to call this F. I'm going to go to 2, 3, and I'm going to put a point. Okay. To the left of 2. So I see, here's 2. I see that I have a horizontal tangent, and I see that I'm increasing from -1 to 2. So I'm going to put a point, like, I don't know, you can put a point anywhere on -1 because it doesn't tell you where you're at. So I just know I'm increasing, and I'm concave up until a half, and then concave down after that. I guess I should put a half somewhere. So let me put my half. Okay, here's my half. And I'm going to put a dotted line. Child, why are you putting a dotted line? That's not a vertical asymptote. That's just letting me know that at half, I should be changing from concave up to concave down. Cool. And then at -1, so you know what? Let me put another dotted line at -1 and another dotted line at 2. So dotted line at -1. That's just letting me know that I should be changing from increasing to decreasing, or decreasing to increasing. And then another one at 2. Okay, no problem. You know what? Wherever you see dotted lines, something's happening. And you know, let me go ahead and label what each dotted line is supposed to be. So at a half, I have a point of inflection. Maybe this will help. And then from at -1, I better be changing from decreasing to increasing. So let me put F changes from decreasing to increasing. So maybe this helps like that. And then at x equals 2, I should be changing from what? F changes from, perfect, increasing to decreasing. All right, I have all my little things in place. So now I can just go. Here we go. F changes from decreasing to increasing. So I'm going to start, let's see, how am I going to start? Decreasing to increasing, and I better be what? I didn't even check my concavity. I better be concave up. Decreasing to increasing, concave up. So decreasing to increasing, concave up. And I'm still now, hold on. Decreasing to increasing, concave up. Right at -1, I have a horizontal tangent because it touches. And then from -1 to 2, I'm increasing, but I'm still concave up until I reach a half. So let me reach a half. So concave up until I reach a half. And then right at half, I change my concavity from concave up to concave down. So I'm going to put a point just to let them know that I'm changing my concavity. And now I'm increasing again, but concave down. See? Boom. And then from there, I have a horizontal tangent, and I decrease forever. And I look like that. Bam! Did it. Call that F. Call your mom, call your dad, call your grandpa. Let them know you did it. Cool or not cool? Okay. All right. We got another one. Same stuff. We're just practicing some more practice. It says, given the derivative of x, determine the following. And it wants to know just the same stuff again, guys. So this is f prime. Where am I increasing? Where is f decreasing? Where is f decreasing? Assuming I have arrows like this, does f ever decrease? Nope. F of x is always, you know what? I'm going to write it differently than usual. Is always increasing since f prime is greater than or equal to 0 over the entire domain. That's full credit. You could have also said f of x, since f prime is greater than 0 from negative infinity to 3, parenthesis 3 to infinity. But there it is. I covered everything. You're never negative f prime, so you have a horizontal tangent at 3, so the graph probably looks something like this. See, you have a horizontal tangent for a moment, but then you continue increasing. Okay. Determine where f of x is concave up or concave down. Concave up from 3 to infinity because f prime is increasing, and you're concave down from negative infinity to 3. So look, here's my graph. So it says, it probably wants me to sketch. Okay, let me write that down. Concave up, and I only say up first because I type up first. Concave up on the interval. I guess I gotta say what, right? F of x is concave up. F of x is concave up on the interval negative infinity to 3 to infinity, and f of x is concave down on negative infinity to 3. And make sure you put y though. I did a bad job here. Let me stretch it here. It's concave up because f prime is increasing on this specific interval. And f of x is concave down on that because since f prime is decreasing on this specific interval. Perfect. And then it says sketch a possible graph. They don't tell me where to graph, like they don't tell me a point. So I can put a point wherever I want. Where do you feel like putting a point at? It has to be x equals 3, but it doesn't matter where. Okay, you want to put it at 3, 2? No? You don't like it? You want to put it at 3, 1? Wherever you guys want. And it looks something like this. Increasing all the way to 3, concave down. So increasing all the way to 3, concave down, horizontal tangent for a moment. Increasing, concave up. See? It looks something like that. And there it is. How do we feel, guys? All right, we got 3 minutes. So let me go ahead and now you guys, well, whenever you guys get a chance, see if you guys can do that. Don't worry about letter D. You know, maybe I'll give you extra points. So let me go ahead and stop this here, stop sharing, and then come back. So let me, what do I do? Stop share. And, okay, I'm going to have to stop the recording. So hold on, guys. Give me a little bit of time.